Hello, and welcome to the Unit Circle learning about the coordinates. I'm going to be spending some time explaining where these coordinates come from and just a few tricks of how to remember them. But what we really need to know in order to know where our coordinates come from are our special right triangles. You may have come across these before in the past, you may not. We'll have to see. We have two special right triangles. I'm going to go over one of them with you, explain how that relates to the coordinates, and then we'll go over the other one. So the first special right triangle looks something like this. We're going to call this a 45, 45, 90. And we call it that because the angles are 45, 45, and 90. Now, it has been found, I'm not going to go through where it's found, you can kind of look that up online if you need to, that the ratio of these sides is that if both of these side lengths are the same, or x, and we can say that since the two base angles of 45 and 45 are the same, this must be an isosceles triangle, meaning that two of the side lengths are the same. So if two of the sides are x, then that last side, or the hypotenuse, is going to be x times the square root of 2. So these are the ratios we have. Now we're going to go through and find out what is x. Now, the way that we're going to do that is taking a look at our unit circle. So if we bring it back to our unit circle, I'm going to highlight right here. I have to think, where do we have 45 degrees on our unit circle? So you do have to know a little bit about degrees before we can do that. And we know that we're going to have 45 degrees right here. So if we were to kind of drop this down, we're going to have 90, and this is our 45 and our 45. So the hypotenuse in this case becomes our radius. And we know that this unit circle has a radius of 1. So we know that x times the square root of 2 is equal to 1. So I'm going to solve for this x value. So if we have x is equal, times the square root of 2 is equal to 1. I'm going to I'm going to divide both sides by the square root of 2, getting that x is equal to 1 over the square root of 2. Now, here's the thing. We have x by itself, but we can't stop here. Back in the olden days, calculators couldn't figure out how to divide if there was a square root in the denominator. So we're going to have to do something called rationalizing the denominator. And that's where we multiply top and bottom by the denominator. So in this case, top and bottom by square root 2. Now, the reason that we do that is because the square root of 2 times the square root of 2 is 2. Square root of anything times that square root of anything is that anything. So we're going to have that x is equal to 2 in our denominator, and 1 times square root of 2 is square root of 2. So we can say that in this case, these side lengths are the square root of 2 over 2. So if I take a look at this coordinate, well, the coordinate is just the lengths of each of these sides. We have x here, we have y here. Well, those are just the side lengths of our triangle. So we can say that, we'll do this in red. We can say that the coordinates here, sorry, I was just setting on my pen color, is square root of 2 over 2 and square root of 2 over 2. Now, if we keep going around the unit circle and finding places where we have our 45-degree angles, that'll also be here, that'll be here, and that'll be here. Now, whichever way we have our triangle facing, be it like this, or what have you, we're still going to have the lengths be the same, except now some of these quadrants are going to, in fact, be negative. So if we take a look in quadrant 2, we can say, hey, here, my x values are negative. So this is going to be negative square root of 2 over 2, and then positive square root of 2 over 2, since the y values are positive here. Please make sure to not put the negative inside the square root. This is not the square root of negative 2. That is something completely different. So please leave the negative on the outside. If we move down to our third quadrant, here both our x and our y values are negative. So this will be negative square root of 2 over 2 and negative square root of 2 over 2. We go into our fourth quadrant, x is positive, y is negative, so this is going to be square root of 2 over 2 and negative square root of 2 over 2. So there's our quarters there. I also realized just now that we haven't really done kind of the ones that we really like if this was on a graph, kind of the easier points. So I'm going to highlight this for us in, yeah, let's do yellow. Actually, let's do red. So here, 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 and here. Ooh, that's hidden, but I'm going to have to move this over just a little bit. There we go. So here, it's as if this center was our origin, and what are these points? Well, in this first one, right over here, we have no rise in our y values, but we go over 1 unit, and our x values, so this will be 1, 0. Up here is going to be 0, 1. Then we're going to have -1, 0, and 0, -1. So those are, I realized I hadn't done those yet. Those are all kind of the nice ones. But this is the first example that we need with a special right triangle. Now we do have one more special right triangle that I want to talk about. And this comes from taking an equilateral triangle and cutting it in half. So it may look something like this. Now if we take an equilateral triangle, so 60 degrees all the way around till we cut that in half, we end up with 60 degrees over here, 30 degrees up here, and then 90 degrees in the corner, which is why we call these 30, 60, 90 triangles. And we know that through research, again, you can look this up a little bit later, the ratio of these side lengths is going to be 2x for that hypotenuse, x for that short side, and that kind of middle side, that's going to be x times the square root of 3. So if we were to orient this so the hypotenuse was the radius, it might look something like this, where we have our 30, our 60, and our 90 right here. So in this example, 2x would be our hypotenuse as well as our radius, and we know that 2x is equal to 1. So we need to go through, figure out what x is, and solve. This one's going to be a lot easier than the other one. So if we have 2x is equal to 1, divide both sides by 2, and I get x is equal to 1/2. Okay, so that means that down here, the shorter side is going to be 1/2. And then up here, if I do 1/2 times the square root of 3, you can think of that as the square root of 3 over 1. So this whole side right here is going to be the square root of 3 over 2. So if I take a look at my triangle in this fashion, well, my short side in this example is my y, or is my height. So that's going to be 1/2. And then that kind of middle side, that's going to be my x. So in this example, we're going to have root 3 over 2 and 1/2. So if I keep going around my circle with this example, move this over just slightly, then we're going to have that same triangle here, that same triangle here, and that same triangle here. But just remember, some of these are now being reflected or in different coordinates or quadrants. So now that here we're in quadrant 2, the x value is going to be negative. So this is going to be the negative square root of 3 over 2 and 1/2. Whoops. 1/2, there we go. In the third quadrant, both of them are going to be negative. So negative square root of 3 over 2 and negative 1/2. And then in the fourth quadrant, x values are positive, y values are negative, so square root of 3 over 2 and negative 1/2. Lastly, if we take a look at our last piece of coordinate, these are actually our 30, 60, 90 triangles, just oriented differently. So I'm going to re-highlight this right here. And we can say that, hey, this is really just 60 degrees here, here's my 90, and then my 30 is now up here. So we don't need to learn another triangle, everything's just switched. Now my x is the short side here, so my x value is going to be 1/2, and my y value is going to be square root of 3 over 2. So if we were to highlight the other triangles that look like this, it'd be here, it'd be here, and it would be here. So you can kind of see this almost has like a butterfly look to it. But just keep in mind as we're going around each of these, some of them might be negative, some of them might be positive. So in our second quadrant, the x values are negative, y values are positive. Third quadrant, everything is negative. And in our fourth quadrant, x values are positive and y values are negative. So this is where all of the values come from. Feel free to rewatch this again. Feel free to have your own memory tricks. If you've stuck around this long, I'm going to show you how, as a high schooler, I memorized these. So I'm going to be moving this up, and then I'll show you exactly what I did. Move this up here. Now, as a teacher, I know how to do this, and I've studied it for a long time, but as a high schooler, I was like, I'm just going to memorize this stuff. So if we take a real rough sketch of the unit circle, I'm just going to show you how I did the first quadrant. Okay, so there's my 3 things. I'm going to start here. So what I did is I would start by dividing everything by 2. And then I'm going to start here in the upper, left-hand corner, and just go down and around. 1, 2, 3, 1, 2, 3, and I'm going to square root everything, or all the numerators. And square root of 1 is just 1, so you can erase those. And there you go. There's your first quadrant of coordinates, so if you prefer that, you can definitely use that trick if you want. I just want to make sure you know where those come from. Just make sure that you reflect everything and make things negative accordingly. Thank you for sticking around. If you have any questions, let me know. If you'd like to learn about other parts of the unit circle, feel free to watch the other videos.